Okay, let's look at some more examples then. So 0.3 recurring. Now also, let's look at the question here. Convert these recurring decimals to fractions using algebraic proof. This is another way to describe this topic, and you could be asked in the exam to do this using these words. Using algebraic proof. It's another way of describing what this process is. Okay, so we start with this recurring decimal. So to begin with, let's call it something. Let's call it R. R stands for recurring. It's a good variable to use in this case. Okay, so then we want to have another expression that has the same numbers after the decimal place. So this is after the decimal place, 3 recurring. So I'm going to find another expression for R. So everything after the decimal place is also 3 recurring. So 10R. 10R would be move everything one place bigger. So that would be 3.333 recurring. Okay. Now you see everything after the decimal place is identical. Then I can subtract these two. So 10 minus R is equal to 3.3 recurring minus 0.3 recurring, which is just like we did here on the board. If I had, let's draw a line here, and I had 0.3 recurring, times it by 10, you get 3.3 recurring. Take them away, you're going to have all of this side here. 3 minus 3 is going to give me 3 minus 0 is going to give me 3. 3 minus 3 here is going to give me 0. 3 minus 3 here is going to give me 0. So you're left with just loads of zeros. So they will just cancel out. You're left with just 3 minus 0. So just, you see everything after the decimal place is identical. So they're subtracting and they're going to cancel. So 10R minus R, which is going to give you 9R. And then you're left with just 3 here because them two are going to cancel. Then you divide both sides by 9. You're left with R is equal to 3 over 9. Now that can be simplified. Divide top and bottom by 3 to get 1/3. Let's look at 0.4.